Okay, in this lesson, 5.5, we're talking about inequalities in triangles. We're going to start off with the triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, the sum, so if you add two lengths of any two sides of a triangle, it's got to be greater than the length of the third side. So we've got triangle XYZ here. We don't know any of the lengths of the sides, but we do know, since it is a triangle, that if we take the length of XY plus the length of YZ, it's got to be more than the length of XZ. And then if we take YZ plus XZ, it's got to be longer or more than XY. And then if we take the last combination, XZ plus XY, it's got to be bigger than YZ. Okay, for any triangle, that's got to be true. All right, so let's look at some examples of how we'll see problems involving this theorem. All right, first set, is it possible for a triangle to have sides with the given lengths? Okay, so in number one, we're given three lengths of a possible triangle, 3, 7, and 8 centimeters. We want to determine, is this a possible triangle? And if not, why? So let's start off. We want to, in pairs, add each of our triangle lengths and make sure that they're bigger than the third side. All right, so let's start off with 3 and 7. So is 3 plus 7 greater than 8?
No. Oh, wait, yeah.
What's 3 plus 7?
10.
10. Is 10 bigger than 8?
Yeah.
Would you rather have $10 or $8? $10. So check. All right, it passed test number 1. Test number 2, let's go with 7 and 8. Is 7 plus 8 greater than the third side that we didn't add together? 3.
Yes.
Yeah, what's 7 plus 8?
15.
15. I'll take 15 cheeseburgers over 3 any day. I don't know about that. Let's 15. I'll take $15 over $3 any day. I might not be happy after 15 cheeseburgers. So let's take our third combination, 3 and 8. So 3 plus 8, is that bigger than our third side, 7?
Yes.
Yeah. Okay, so yes. This is a triangle. Or this could be a triangle.
I didn't even see the beginning. And then it finished that. Oh.
All right, second example. We've got a 3, a 6, and a 10-foot side. Let's see if this is a possible triangle. All right, let's start off with our first two sides. Again, we're going to do the same thing. We're going to add them up and make sure that the sum of those two is bigger than the third.
That's a 6? I thought it was an 8.
Yeah, it's supposed to be 6. 3 plus 6, is that greater than 10?
No.
No, what's 3 plus 6?
9.
9. So 9 is not greater than 10.
Really?
So, no, this is not a possible triangle. It's impossible to make a triangle out of a 3-foot board, a 6-foot board, and a 10-foot board. Okay, second type of example. Says the lengths of two sides of a triangle are given. Describe the lengths possible for the third side. All right, so they give us two sides. They want us to say, well, what could a possible third side be? And we're not going to list every single possible type. What we're going to do is we're going to give a range of values that it could be. Okay, so if we start off by adding the two like we did just then, 4 plus 6 is 10. But now we always want the sum of two sides to be bigger than that. So we want our side, let's call our side X, to be less than 10. Right? Because if it's longer than 10, then the 4 and the 6 side, they're not long enough to connect that triangle. But what we also want to do is take those two values we're given and subtract them. Okay, so first step we did was we added them. Second thing we're going to do is we're going to subtract them. 6 take away 4 is 2. And it turns out, yeah, it's got to be longer than 2. So it's got to be any value between 2 and 10 are our possible lengths for the third side of this triangle. And that's what our answer looks like. All right, let's look at number 4. We've got a 9 and a 14. All right, so step 1, we're going to add them together. What's 9 and 14? 23. So that's our upper bound. That's the longest that it can be. And our smallest, we want to subtract the 2. Always take the bigger minus the smaller. What's 14 take away 9? 5. So we want our, again, we'll call it x for our length of our side to be between 5 and 23. Yep. So it could be any value. It could be 5.1. It could be 22.9. It could be 17. That third side could be any length between those two. And then maybe we should put our units on the end there. So inches, and then this one's in feet. All right, next topic. Theorem 510 says, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Interesting. All right, let me fill in my angle symbols here that should be there. All right, so we've got triangle XYZ. This theorem says that if you have any two sides of a triangle that are not the same length, the longer or the bigger angle is opposite the longer side. So our longest side in this triangle is XZ at 15. That means that the angle opposite that side has to be the largest angle. So XZ is the longest side, so that means that angle Y is the biggest angle. Okay, and then likewise, XZ is greater than XY, so 15 is longer than 8. Therefore, the angle opposite XZ has to be bigger than the angle opposite XY, which is Z. So the measure of angle Y has to be bigger than the measure of angle Z. Okay, so longest side opposite largest angle. It also goes to show that the smallest side is opposite the smallest angle. All right, and vice versa. So if we want to list the angles from smallest to largest, okay, so looking at this example here, we want our angles from smallest to largest in triangle XYZ. So we need to look at our sides because we don't know any actual measurements for our angles in this triangle, but we do know the side length. So what's our shortest side length? 8 XY. So what angle is opposite XY? Z. Good. So angle Z is our smallest angle. All right. What's our middle length side? Middle length side YZ, and then angle X is opposite that. And then what's our largest angle? Angle Y. Okay, so from smallest to largest, Z, X, Y. All right, another example. It says list the angles from largest to smallest. So when you come across a problem like this, you got to be careful. You got to read the directions. So we're looking for 3 things. Angles. So what type of figure am I naming? And then what direction am I going? Largest to smallest, smallest to largest, or it might say increasing, decreasing, that sort of thing. All right, so we don't know any of our angle measurements, but we know our side measurements. So we want to find the largest angle first. Largest side is RT, so opposite that is angle S. Middle side is RS at 13, so opposite that is angle T. And then what do we have left? R. All right, next up, one more theorem. Theorem 511 says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay, so two angles of a triangle not congruent, the longer side lies opposite. Really, it says kind of the converse of the last theorem. Okay. So now it doesn't tell you what the actual measures are, but it just kind of compares the two. Which one's larger, which one's shorter. Okay, so if we look at triangle TUV, then angle U at 58 degrees is smaller than angle 62. So then that means if if the measure of angle U is less than the measure of angle V, then this theorem says that the side opposite that smaller angle, which is TV, has to be less than the side opposite the bigger angle, which is UT. Okay, that's all it says. It doesn't give us an actual measure. It doesn't tell us anything more than that. Now, they just give us two angles. Can we find this third angle? Yeah. So if we add these two up, 58 and 62 gives us 120. If we take that away from 180, since we know all three angles in a triangle add up to be 180. Good. So we know angle T is 60 degrees. So in triangle TUV, if we look at this example here, which side would have to be the shortest?
TV.
TV. So TV is opposite the smallest angle. Therefore, it would have to be the shortest side. All right, next example. We want to list the sides from smallest to largest in triangle ABD. Again, we're only given two angles, so before we do this, we want to find that third angle. Before we start listing any of our sides, we want to find that third angle. So let's add these two up. We know that 39 plus 54 plus whatever the measure of angle A is has to be what?
180.
180. Good, good, good. All right, so let's add these two up. 39 and 54 makes 93, right? Somebody with a calculator want to check me on that? Subtract 93 from both sides. 87. All right, so the measure of angle A is 87. So sides from smallest to largest. What's our smallest angle?
D.
D. So if we go to the opposite side, which is AB. All right, and then we go to the next biggest angle, 54, which is opposite AD. And then what do we have left? DB. Okay, so from smallest to largest. All right, so next up, what I would like for you to do, if you're watching this lesson at home, is to try these next problems. You can pause and copy these down in your notes. Ooh, let me go back to that one. Pause it on each pair, copy them down in your notes, and come in on Monday and we'll talk about them. And that is your homework for the weekend.
What are you talking about? He wants to text her video.
Dude.